It's Monday afternoon in Switzerland. It's Space Café UAE time. Our new format, the Space Café UAE with Abdulla Abu Wasel and his great guest, will begin soon. As always, we appreciate your participation and your ongoing feedback. I'm Thorsten Kriening, publisher of SpaceWatch.global. We are a Switzerland-based online platform for information in and about space and new space activities in a geopolitical context. With Abdulla, we found a friend and a wonderful host for our Arabic outreach. I know many of you are already familiar with our website, our bi-weekly and daily newsletters, and the Space Café podcast. We also keep our fan shop open online for you to support us actively and become a space watcher. If you have missed any of our previous web talks, we have an archive on our website in the events section and on YouTube. We will host our Space Café UAE live regularly. And with that, my job is done for today, and I like to hand over to your host in Abu Dhabi today, Abdulla. Over to you.
Thank you so much, Torsten, for the brilliant introduction as always. Ladies and gentlemen, welcome to the second episode of Space Café UAE. My name is Abdulla Abu Wasel. I'm the managing associate of Wasel & Wasel. I'm the secretary to the board of directors of the Hague Institute for Global Justice, and I'm a member of the Space Generation Advisory Council, which my guest is as well, but we'll touch on that a bit later. Now, my esteemed guest for today is Mr. Sahith MADARA. Sahith is the UAE's national point of contact for the Space Generation Advisory Council and is currently doing his ITP with Airbus Defence and Space on the optimizing of the OneWeb satellite ground station's operational availability using model-based systems engineering. He was also privileged to be a part of Masdar's highly selective Future Sustainability Leaders program. Now, Sahith has contributed to building the second UAE Meteor Monitoring Network, UAE MMN Yahir Tower, which was sponsored by the UAE Space Agency. And now, without further ado, and ladies and gentlemen, please help me in welcoming Mr. Sahith MADARA. Sahith, it is an absolute pleasure to have you here. I know you're currently based in Toulouse, France, so I have to ask, what are you doing there, and where are you going to be next?
Okay, first of all, I would like to thank you, Abdullah, for the great introduction, and Torsten for the wonderful initiative of Space Watch Global. I really appreciate it. Okay, what I'm doing in Toulouse, I'm actually here for my advanced masters at ISA Supero, which is the Higher National French Institute of Aeronautics and Space, which is run by the Ministry of Defense. So I'm doing my aerospace systems engineering over here. And along with it, I'm also doing my ITP real-time project with Airbus Defence and Space, as you have said. And my next step, as you are asking for, is going to be, I'll be joining the Euroconsult Paris office next month as a space consultant. Stage.
Well, congratulations on that next step. I'm very excited to see where you're going to go with this. But before we go into your future, I want to go back to your past. Now, when did you first become fascinated and embedded in the field of aerospace engineering, and what drew you to it?
It was actually not a sudden career move. It was a collective of multiple experiences throughout childhood, basically. So like NASA's Apollo program and Indian space program development and books from Carl Sagan and Dr. APJ Abdul Kalam and various other scientists I was reading. So that's how I was actually fascinated in the field of aeronautics and space. Mm-hmm. So when it came to choose my bachelor's program, then I thought, okay, well, why not now? So I thought it could be one of my first steps towards it. Then that's how it all began.
I think you took the right step, my friend. I mean, you look well suited for the role. But when I say well suited for the role, like we mentioned earlier, I don't know much about your role. So could you tell me exactly what an aerospace engineer's job entails? What are your day-to-day responsibilities?
Okay, before coming to France, I was working for the space agency projects in the UAE. So I was working as an aerospace research engineer over there. So we actually try to solve some of the hard challenges every day in our day-to-day work, basically. So I can say some of them, for example, we do research proposals for research proposal for aerospace projects and applying for funding with national government space agencies, writing scientific papers, and presenting in international conferences. And and in the technical part of view, we do the design, development, as well as testing of the satellites, science outreach, switching between various projects, what we are working on, and ensure almost all of our projects meet this quality standards set up by the International Space Organizations. Yes.
I mean, you kind of answered my next question here, which
Okay.
is what projects have you worked on in the past? But let me phrase this a different way. What is one of your favorite projects that you've worked on? A project that you feel has really made a significance and impact in the world?
Okay, I can actually talk about two of the projects what we were working on before. One was the Sharjah's first 3-unit CubeSatellite project, which was named Sharjah Sat-1. So it was mainly, it's going to be launched by end of this year, hopefully. That was one of the project. And the second project was the UAE Meteor Monitoring Network, which was sponsored by the UAE Space Agency as well. So I can talk about the UAE Meteor Monitoring Network, where we have a number of towers, 3 towers throughout the UAE, where we have cameras on it, and we observe throughout the sky and how many meteors are falling from the sky. And we also train the drone using machine learning and deep learning algorithms, so that like these drones can go into the desert and search for the rocks instead of we going manually.
Yeah.
So this was one of the projects. It was really inspiring. It was really good, but it's not finished yet, but it's still under process for getting more accuracy.
Okay. Well, I mean, that's very interesting, I have to say, because I was looking into the Yahar Tower, the one you just mentioned, and data online is quite limited. So I'm glad you were able to explain that to me in a mundane way, because I don't really get the nuts and bolts of this whole thing. On that, let me ask you, what is the difference between an aerospace engineer and an aeronautical engineer, if there is a difference?
Okay, there is a difference, of course. It's like aerospace engineering is a mixture of astronautical engineering and as well as aeronautical engineering. Astronautical engineering consists of space systems and space exploration and all these. And when we're talking about aeronautical engineering, it's basically only aircraft. So there is no spacecraft inside it. So if you're talking about aeronautical, it's only aircraft. And if you're talking about aerospace, it's astronautical plus aircraft. So you study both the concept together. So
okay, that makes perfect sense. You're better at explaining things than Google, I must say. So how do you find the field of aerospace engineering has grown in the last decade with the rise of space missions from both the private and the public sector?
Yes, actually, it's incredible to know that the growth is really unimaginable. Because if I see the global space economy, it has changed rapidly from this recent years. Started with companies like SpaceX, Blue Origin, and now various governments are showing interest in establishing national space agencies, and that's really inspiring. And like Jack Ma said, the CEO, the chairman and founder of Alibaba, that everything starts with a leader's vision for the next 10 years, basically. So that's how it started. And when I'm talking about the various national souvenir funds which has been investing in various risky technologies in the field of space, and other like the recent ones in the UAE with the Silver Lake and Mubadala taking stake in G42, which is the one of the AI companies, and the collaboration between various countries for various space projects and also with various private companies is really important. Like recent one, which was done before 2 days back with NASA choosing SpaceX for landing the next Americans on the moon. That was one of the inspiring one. And 2 days news about the NASA Ingenuity helicopter succeeding its first flight on the Mars was historic and inspirational for the future generations. So when we talk about this, it goes on. So yeah.
That's absolutely. I mean, when I was looking at the collaborations between NASA and SpaceX, as a lawyer, I try to go for the contracts immediately. And I could only find one contract, which is there's an agreement that binds them to disclose where the other's satellite is. And that's, I think, the only agreement between the two, considering how much they've worked together. That one agreement is the one between the two. So hopefully they can develop something on a more escalated scale. And on that note, what current developments or trends that you're seeing in the space sector excite you the most, and why?
Oh, there are a lot. Okay, if I talk about a couple of them, there is space tourism and urban air mobility. The companies like SpaceX and Virgin Galactic and Lilium, these are some of the companies who are working on it, and it's really inspiring. And some of the most important technologies to be developed in the space field currently are like high-level communication system for deep space missions. This is one of the most important one, and Earth observation capabilities using different imagery such as hyperspectral imagery. Instead of, like, for example, what we see as an image, it's just RGB, which is red, green, and blue color, basically, which is visible to our eye. But when we are talking about hyperspectral, it solves a lot of problems such as agriculture issues like crop diseases, for example, and rural fields and oil and gas field refineries. It has a lot of other good imageries. And many private startups are coming up into this picture in various countries and challenging the future of technology. And that's really wonderful. And if it goes in the similar way, and even I think we are going to go to Mars in the upcoming decades to come. And along with all of this, the government supporting the private companies and space policies changing as per the developing needs and the requirements of the industry is really required, and it's really happening right now in the current context.
You know what? I'm very excited, I have to say, to go to Mars. There's a lot of people who, when I ask them, would you ever go? They always tell me, oh, I don't know, because Elon Musk wouldn't go. I personally would be the first person to book a seat on that flight. But I have to tell you, since I discussed Elon Musk, I touched on it a bit, and this is something that we were talking about before the event started. What are the differences between the technical side of aerospace engineering and the business side?
Oh, okay. When we're talking about the technical side of the aerospace engineering, we talk about engineers, what engineers are doing and what scientists are doing, what researchers are doing, because there are companies such as Boeing, Airbus who are working on real projects, and there are academia who are working on academic projects. This is one side of it, and the other side of it is consulting field. So it's like, for example, a client has the money and he wants to invest somewhere, for example, like he wants to set up a launch site. They come to you and ask, okay, what should I do now? So the consultants, they do the entire market study for them, and they show that, okay, this is what the current market is going to be, and yeah, for that you pay. So it's like you need to have a business and technical knowledge for one part of it, and for engineering segment you need to have the technical knowledge. So these are the two basic, and along with all of these you also have lawyers, you also have doctors, you have also different, like various majors are involved in the space sector. So it's not only restricted to engineers, basically.
Well, I think after this call, we're going to have a private call so you can give me an intra-market analysis so that we can find somewhere for me to set up my launch site. But when we talk about the technical side, in preparing my questions for you, I was thrown into this world of mathematical equations and in-depth discussions on scientific topics that just went right over my head. So I have to ask you, just one of the questions that immediately popped into my head is, can you explain to us what a stress analysis is?
Yes, a stress analysis is basically a series of tests that will help you see how the materials and structures you create react under force or pressure, basically. So, okay, let us drill down and state it in simpler terms. For example, any aircraft structure, either metallic or a composite material, needs to sustain applied limits and ultimate loading. So basically, the almost all the loads what are actually happening in the flight in the sky, we are testing it below itself.
Okay.
So that's the thing in basic terms.
No, that's perfect. You explained it perfectly. So that's one of the tests that you do. What other tests do you perform when testing materials or prototypes before development?
Oh, okay. There are actually based on application and based on the satellites. There are a number of tests what we do. Like for example, when we're talking about satellites, we do communication, spacecraft communication. We do structures and material test, integrated power test, thermal management test.
Mm-hmm.
Along with all of these, we do guidance, navigation, and control, aerodynamics, entry, descent, and landing. There are multiple tests we do, but based on the level of the spacecraft again.
Okay. So, I mean, from what I've seen and from what's obvious is there's a lot that goes into ensuring a space mission is successful, as there's always a lot on the line. So can you tell us what testing, other than the testing done on the materials, is done in aerospace engineering to ensure the successful launch of a space mission?
Oh, along with all, like I did not mention couple of the testing such as integrated environment testing, for example.
Okay.
It's like
And
launch, space, and re-entry environment. Like these are only for like launching astronauts, for example, like this kind of stuff. Electromagnetic interface, compatibility environment, water recovery systems. It comes under environment control and life support systems. This comes under that. So there are like a couple of these, like if I just mentioned, there are like so many tests which goes on. So like these are some of the main important tests which they conduct based on the application of the mission.
Okay. And I know I'm trying to figure out a way to phrase this that doesn't give me a broad answer, but can you tell me something about astrodynamics? What, as in your job as an aerospace engineer, because this is one of the questions we received from Sanjivan, excuse me, I'm sorry. And he's wondering if you could tell him something about astrodynamics. And I'm trying to figure out a way to phrase this, but in general sense, could you tell us something about astrodynamics?
Okay, astrodynamics is not my research domain, but still I can explain you what's astrodynamics. For example, we launch a satellite to space, okay? And there are new defense systems which it's like you're targeting in the space, and it's what is it called? Okay, you're blasting a satellite in space, for example. So there are a lot of space debris. It just spread across the Earth. So you don't know. Okay, through astrodynamics, you study the orbital mechanics, you study the trajectory analysis, you do all of this to find each and every segment of it. Where is it? At which location? Like the precision level is very accurate. So, but it's still under process. But mostly a lot of government projects are working on this in the US, NASA's projects, and some of the academias, such as University of Texas in Austin. There is Professor Moriba Jao, who is well known in the field of astrodynamics. So yeah, basically this is.
When you say you're not in the field of astrodynamics, I don't believe you one bit after hearing that answer, Sahith. I have to be honest. But you talked about targeting, and this is something that I want to get into in my next question. In a recent video that went viral, researchers at the University of Pennsylvania orchestrated miniature quadrodes to play the James Bond theme, which is actually my ringtone. And the bots know each other's locations, and they avoid collisions thanks to a central system that plotted their locations in space. And the US Air Force recently released a video showing how tiny drones will soon be able to similarly swarm together for the purpose of surveillance and targeting. Boeing is also working at creating a swarming system for larger drones. So Sahith, my question is, how far do you think we'll be able to go with the development of craft-to-craft communication? And what are the benefits of advancing said communications?
Okay, as you said, I have seen that video, what we are talking about. It's really good. As I have already spoke about before, the communication system is one of the most important in any deep space mission or space mission. So the craft-to-craft communication is really upgrading day by day to an advanced level. So basically, if you're talking about at its simplest, space communication relies upon two things. The first is transmitter and receiver. A transmitter encodes a message onto electromagnetic waves through modulation, and the receiver collects the electromagnetic waves and demodulates them, decoding the sender's message. This is the basic concept within it. But when you're talking about robot swarm coordinates, such as like what the James Bond team is doing there, it's really important, and a lot of universities and research organizations are working on it. For example, one of the what I can talk about in Caltech in the United States is working with NASA JPL for one of the projects where like herding bird strike avoidance, especially when for example when that aircraft is taking off, there are a lot of bird strikes happening. So using a drone, it deviates the direction of the birds. So that happens using aerial swarms. That's one of the technology which they have developed. So there is a huge communication between the craft to craft over there. And the second one is ISS docking, International Space Station docking with the other modules with such as from SpaceX or any other ones. So similar to this, there are a lot of things comes into consideration when you talk about communication, such as antennas, space relays, bandwidth, data rates, and so on. There are many. So yeah.
That's breathtaking. Honestly, I'm very excited to see where this advancement is going to take us. And when we talk about advancements, earlier we discussed G42, or you touched on G42 a bit, which is, like you said, an artificial intelligence firm. And on my last episode, I got to speak to the Vice President of Special Projects, Talal Al-Qaisi, and the work he's doing with artificial intelligence. So now that I have you, I want to know what the best of both worlds here is. And how do you see artificial intelligence impacting the aerospace industry in the years to come?
Oh, artificial intelligence, it's playing one of the major roles in today's world, because whatever we do, we are playing out with data. Data is going to be the next oil. You can say that. So our role mainly now is to know what are we going to do with this data. So where are we going to use this? Using machine learning, using deep learning. There are various methods what we are using in artificial intelligence. And when we're talking about a couple of applications in the aerospace industry, I can talk about product design such as NASA Starshade project. That's one of the important projects of NASA, and developing lightweight structured composite materials for fuel efficiency in the aerospace industry. Because when I was checking in 2019, 97 billion gallons of fuel were used only in aviation industry. So even companies like Airbus is focusing on hydrogen aircrafts. It's a new concept which is still under development. And it's also used in efficient supply chain management, and improved customer service using chatbots are one of the evident models for artificial intelligence in aerospace industry.
That's absolutely crazy. The figure you said, 90,000 gallons, is being used. And that is actually a perfect segue into my next question, which is the fact that traffic to the moon is going to pick up this year. And space transportation companies from SpaceX to Blue Origin are teaming up with NASA, like we said, with their sights on a valuable resource. And that's the hundreds of millions of tons of ice at the poles of the moon. Now, some geological analysts say that the market for space water will be worth $206 billion over the next 30 years. This would allow rockets to move further through the cosmos and eventually to Mars, which hopefully me and you will both be on that flight. And considering it takes a colossal amount of fuel, like we said, to get to the moon, do you think that refueling stations for rockets situated in space could be a solution to this issue in the coming years? And what do you think will be necessary to engineer this into a reality?
Okay, so when we're talking about this, in the recent news as well, NASA is sending a robotic fuel station to space to refueling. That's one of their solutions. But when you're talking about other countries like Russia and China is building a moon base together with their collaboration. But Elon Musk has also spoken before about his goals to establish humanity as a planet-hopping species. In that, the idea would be to establish a fuel station along the way. On the rocket can move on further using their Starship project. That's one of the crucial ideas, and it's made up of a stainless steel rocket. So the fully reusable design is powered by the reactor engine, which uses liquid oxygen and methane instead of regular rocket propellant. So okay, when we keep this aside, there are many researchers in the in United States, in the Colorado School of Mines, Astrorobotics, or Honeybee Robotics. These are some of the one of the new company which came into the picture, who are working on moon water into rocket fuel. They wanted to convert them instead of taking from Earth, they wanted to convert the water on the moon into rocket fuel.
Okay.
So that's the technology currently they are working on, but some say it's hard to get to those shady locations in the lunar south pole. Why don't we get the oxygen, which is 80 to 83% of that consists of the propellant that we need through solar power? So that's another concept people are working on. So there are many concepts which are going on. So it's still under trial phase right now.
Okay. I mean, fingers crossed, because I think I'm very excited for the next man on the moon or woman on the moon mission. And that's definitely going to be something that I want to live for, because I obviously was not alive for the last one. So I'm very excited for that. And before I go into my next question, Sanjeevin has another question. Thank you so much for these questions. Absolutely outstanding, Sanjeevin. And his question is, why nuclear propulsion is not used in rocket launching, like solid, liquid, hybrid rockets?
Nuclear propulsion is not totally used, but it is still used in some of the defense missions. It's still used, but it's not widely used because firstly it's really expensive and it takes a lot of storage capability. So I can say that much for now. Yeah.
Perfect. Thank you, Sanjeevin. I hope that answers your question. And please feel free to send in more questions. We are loving these questions. So my next question is, we're both members of the Space Generation Advisory Council, which is a non-governmental organization which aims to bring the views of students and young space professionals to the United Nations, space industry, and other organizations. Now, on another note, the average age of team members that worked on the UAE Space Agency's highly successful Mars mission was 27. We are seeing the prevalence of youth in the space industry, and you're an exemplary beacon of that, Sahith. So what do you think the benefits of youth in the space industry is, and what developments do you think will be brought about by youth in the space industry?
Okay, I think we were just touching upon this before as well. Space requires people from various industries, because this is a misconception between the youth, especially that when you wanted to work in space, you need to study aerospace. It's nothing like that. So you can see, for example, you're having a space company and it got into litigation. You go to space lawyers.
Exactly.
Like when we are talking about like ISS, like doing some research in ISS, you talk about doctors, bioastronautics. There are a lot of it's there in different fields. You name it and it's there. So the only thing is you need to find, there are civil engineers used basically. So it's to build it. We have a lot of different applications into it. And there is a huge opportunity for the use in the space sector, because it's going to be the next billion-dollar industry, and you can even say trillion-dollar industry in the next decade, basically. And we also need a fresh way of thinking in a new perspective from the youth, and that's really important. As it is in the starting stage in many countries, it's the opportunity for the youth to learn and expand their technical skills for the future. And space applications can serve in various industries, such as, for example, Earth observation, government space affairs, maritime communication, space exploration, and so on. But the only thing is the level of space education awareness is very less in the developing countries. And that's one of the main things we need to address in the future. And some of the organizations such as SJC, American Institute of Aeronautics and Astronautics, Royal Aeronautical Society, many of the organizations such as these are addressing the issue with the developing countries, and they're training them for the future. And that's really important because they're going to be the future generations. So yeah.
That excites me a lot, because I've seen the capabilities of the youth, and it is definitely a misconception that you have to be an aerospace engineer to go into the field. But on that note, as a person who's in the legal field, for us lawyers, the Magna Carta, the document that we look at, is the Outer Space Treaty. And right now there hasn't been a legal framework that has been developed. So we're hoping that in the next few years there can be a bottom-up approach or even a top-down approach where a new legal framework can be established to assist with the new regulations of the private sector. So earlier in the episode, we talked about you being in France, and I was wondering if you could provide us with a comparison of France and the UAE's approaches in the space industry. What are the differences you're seeing between the two nations and their ultimate vision and goals?
Okay, when we're talking about UAE and France, these two are entirely different countries from different regions. And UAE is a very young country, and their space agency itself was formed in 2014.
Yes.
But if you compare with France, the CNES, which is the French space agency, was established in 1961, basically. So it's like both are two different countries. But if you see in the space perspective, they have very good collaboration between the countries in the field of space, basically. And the project, if you see, both of them have launched Mars missions, astronaut missions, and so on. And if I talk about UAE in specific, UAE is having a next 100 years plan, which is the Mars 2117 project, to build an entire Mars colony in Dubai.
Yes.
So it's the leadership of the UAE is giving an assurance to the youth that for the next 100 years, there is a job guarantee for you guys. So space is not for one mission or two missions. So you have the next 100 years dedicated to it, and there is funding for you. So both the countries have very good collaboration in various sectors. For some other sectors, like in aeronautics, like Airbus Defense and Space and Airbus Commercial is working on it. And space, French Space Agency is collaborating. If you talk about defense, there is Dassault systems for some of the military aircrafts. So all of these, and along with all of this, the diplomacy between the countries is also really wonderful in various different industries, not if you even exclude space. Okay, there's the last thing I would like to address is education. There is a huge education difference between UAE, Middle East, Asian countries, and France. Because the thing is, in all these countries, you focus on research, but in France, it's a bit different because they've mainly focused on practical way of working. So like, for example, when we're talking about any of the universities, we have 80 to 90% professors coming from Airbus, Dassault Systems, Safran. Imagine your professors are coming just from the industry, and they're talking to you about the real problems, what they're facing in their life. So even once you graduate, so when you go to that company, it's nothing new for you. You already know everything. So it's like practical way of learning instead of just like reading in books. That's what I have observed. That's one of the major differences between some of these countries. But I think even other countries are evolving themselves right now.
And I really like that, because I think that, in my opinion, the easiest way to learn is through the practicality of things. It's always easy to write a paper, a thesis, whatever it may be, but getting into the practical niche of things is always the best way to dive into it, to be embedded into whatever it is that you're doing. And I really like how you mentioned that the UAE is young, because I think the UAE is a symbol of the youth across the world. It's a young country that has accomplished an exorbitant amount in such a short period of time. And that's something that makes me proud to be a resident of such a nation. So before we go into the audience's question, I have to ask you, do you have any last remarks you'd like to make? What do you hope to see in the future? What do you think is going to come about in the future in the field of aerospace engineering and in the space industry in general?
Oh, in the space industry in general, it's gonna be wonderful, and we cannot guess what's gonna be, because, for example, even when we're talking about Elon Musk, he was talking about the next 20 years plan, but right now they decrease the time to next 5 years, next 3 years, what they're gonna do, and that's really inspiring. So when we're talking about the future, I'm really inspiring for the space tourism, which is, I think it's going to be coming in the next 10, 20, 10 years. It's going to be possible to the moon. If you're talking about Mars in the next couple of years, but the only thing is the skill polarization between the people who are having the knowledge in the current trend, such as artificial intelligence we were talking about in the space industry. So that should be covered because there is a huge skill polarization happening between this. So that should be covered. That's one of the major, because youth are the future, as you know. So that should be covered. That's one of the main things. And I also tell that try your best instead of doubting yourself. Like when you wanted to do something, just do it.
Correct.
So my last and final thing for the youth is, whenever there is a complaint, what I believe in is, whenever there's a complaint, think that's an opportunity for you, and take that opportunity and go forward and
Correct.
make it a reality.
I absolutely love that. You're right. I mean, every challenge in life is an opportunity for you to excel and to show your true nature. And that's something that youth has to take into account. And that's something that I hope as a human society, we continue to develop on. So we'll now go into the Q&A portion with the audience, and Sanjeeveen had some very excellent questions. So please let us know your questions, and we are happy to answer them. You can share them in the Q&A box like Torsten showed you at the start of this. Go ahead, ladies and gentlemen. Sahith, since we haven't received any questions, let me ask you, how does it feel to be the national point of contact for the Space Generation Advisory Council? Because that is a very lucrative role that you have, and we talked about this privately, but that was a role that I applied for myself, and they told me Sahith has it. So tell me.
Yes, Abdullah. It's really inspiring, and it's a bit demanding, and as well as there's a huge responsibility over you as well, because to inspire the youth, like what I believe in basically is, like, you have a lot of knowledge. Why don't you put it out there? So you share your knowledge with hundreds of it might be students, because it's like I'm giving knowledge to you. You give it to someone else. It's like a tree. You need to spread it all around the world. So like in SGAC, it's about the youth basically. We organize many events, and it's throughout the world basically. So like in the UAE, it was just established before 2 years back. So when I have we have signed the MOUs with UAE Space Agency. We have signed with Mohammed bin Rashid Space Center, couple of other organizations as well, and it was really inspiring, and to see the excitement in the youth. It was really much, but the only thing was, at that point of time, there were no one to direct them towards the right stuff, what you should do, where you can get the information from. So I think now the awareness is really there, and also with the Hazal Mansouri and the astronauts, they were really inspiring for the youth. That was one of the, if you speak to any of the UAE youth, which industry you want to go, they'll say space. What you want to do, they want to be an astronaut.
And I really like that, because I feel like we've gone back to the past here. When I was young, I think when we were both young, the first thing we said is, I want to be an astronaut. Whenever mom and dad would ask, you'd always say, I want to be an astronaut. I want to go to the moon. Somewhere along the line, it changed for me and you. You became an aerospace engineer. I became a lawyer. So I don't know where we lost track of the astronaut there. But I'm sure one day we'll go back to it with our trip to Mars. Thank you so much, Sahith, for an absolutely wonderful talk and for being my guest. You truly are a wealth of knowledge on aerospace engineering, and I'm glad we had the fortune to listen to you today. I'd like to thank the entire team behind the scenes for doing a great job every week and for ensuring I can just be a pretty face in front of the camera whilst they all do the valuable work. So we have a lot of upcoming events. As you can see on the screen in front of you, our next session will be on the 20th of April at 4 p.m. And that will be 33 minutes with Teresa Hitchens. And on the 27th of April, again at 4 p.m., will be 33 minutes with Professor Chris Welch. And then on the 29th of April is my colleagues across the pond is Space Café Scotland. And that's always a fun one. Those guys are outstanding over there. Now, the 30th of April at 10 a.m. will be Space Café Greater Bay Area, China. And I love these guys because they're part of the regional group here. And on the 4th of May, we have 33 minutes with Timadio Onyasan. And on the 6th of May, we have Space Café Germany, the second episode. And lastly, 7th of May, we have Space Café Canada. So please make sure to register for all of those because they're all very exciting. And trust me, they're all much prettier than I am and much more knowledgeable than I am on these topics. So you can learn a lot from them and you can have a lot of fun. To our lovely attendees, I want to sincerely thank you for joining us for today's talk, and we hope to see you again. But until then, please stay well, stay safe, and stay healthy. Ladies and gentlemen, good night and farewell.
Thank you, Abdullah, for this wonderful session. I really appreciate it.
Thank you so much, Sahith. It was absolutely my pleasure.